Welcome to Why Didn't You Just Say That? A new YouTube channel by yours truly, where I go over AP pre-calculus concepts in hopefully a much simpler way. I'm going to try and make these videos 5 minutes or less so that they're nice and bite-sized for you for just review or providing a little bit of clarity to different concepts that we're learning in class. We're going to start with 1.1, which is change in tandem. And it sounds really scary, but it's just explaining that as one variable changes, the other changes as well. We're going to start with domain. So domain is just all the x values. We've seen domain before, like what x value is present on this function? What x values can I plug into the function and still receive an output? So the output is our range, and our range is all the y values. So range, y values, output, they're all the same thing. But in AP Pre-Calc, what we are going to be doing is switching our vocabulary. So instead of saying X, we're going to say input. Instead of saying Y, we're going to say output. So as our inputs change, our outputs change. And how do they change? Well, one of two things can happen. It can either be an increasing function, where as the input values increase, my output values increase. Or it could be a decreasing function, where as my input values increase still, because we're still moving left to right, my output values drop or decrease. Increasing, decreasing, those are the two basic ways. It could be straight across, but that's when y equals a specific number. All right, well, what else do we need to know? Well, we need to know about zeros. So we've heard the term zero before. And basically, it's just an x-intercept. We know y-intercept from slope-intercept form. It's where it crosses the y. So an x-intercept is where it crosses the x. And we call them zeros because it's where y equals 0. And it gives us information further on about restricting a domain in real-world scenarios or things of that nature. Last thing I want to discuss is concavity. So concavity should be a newer term that you haven't discussed in, say, Algebra 1 or Algebra 2, but concavity talks about the rate at which things are changing. Is the rate increasing or is the rate decreasing? So an increasing rate would look something like this, where it's concave up. Concave up tells me that as I go along my input, as I go along the x values, the rate at which it's changing is increasing. And if the rate is always increasing, you're going to get a concave up function. If the rate is always decreasing, you're going to get a concave down function. So it does get a little bit confusing when you talk about negative rates. A negative rate would be going in the downward direction. But as it gets steeper in the negative direction, it's actually decreasing. So it gets tricky here when we're looking at concave up, because this has a steeper slope, but it's a negative steep slope, as opposed to, say, this part here, where the slope is starting to level out and get closer to 0. You can have functions with both concavities. In the beginning here, we see that it is concave down, and that it certainly switches, and then it at some point switches to concave up. So as it's going concave down, my rates are decreasing, decreasing, decreasing. Boom, right here at this point, my rates are now increasing and they're shooting back up. And we call this switch point a point of concavity. I'm sorry, a point of inflection, my fault. So this is a point of inflection where the concavity changes. That's it. That's 1.1, change in tandem. Thank you so much for watching. Bye.